440 million years ago, the Earth was silent and strange. No trees, no grass, no flowers, no animals walking on land. It was a rocky, empty world with endless wind and not a single sound of life above the sea. But something was changing. This was the Silurian period, a forgotten chapter of Earth's story when life began its first cautious steps onto dry land, not with creatures or crawling beasts, but with something much smaller, something greener, and something taller than anything else on land at the time: fungi. The oceans were still the heart of life. Trilobites, corals, armored jawless fish, and giant sea scorpions ruled the water. But above the waves, on the dry, ancient supercontinent of Gondwana and its neighboring landmasses, the earliest pioneers of land had arrived. And they weren't animals. They were mosses, liverworts, tiny, soft plants that clung to wet rock near the shoreline. They had no roots, no flowers, and no seeds, but they were alive. For the first time in Earth's history, land was no longer lifeless. These tiny plants soaked up water and sunlight and began pumping oxygen into the atmosphere. It wasn't much, but it was enough to start changing everything. As they grew, they slowly built up layers of organic material, dead leaves, decaying stem excreting the first primitive soil. But these mosses weren't alone. Towering above them, like silent alien giants, stood the strangest life form on the planet: prototaxites. This mysterious organism looked like a tree, sometimes growing over 8 meters tall, but it wasn't a plant, and it wasn't a tree. Prototaxites was a fungus, the largest living thing on land for millions of years. Its body was made of densely packed tubes called hyphae. From the outside, it looked like a massive, tapering pole rising straight from the rocky ground. No branches, no leaves. Just a smooth, pointy trunk of living fungus. And it dominated the early Silurian landscapes. For years, scientists debated whether prototaxites was a fungus, a lichen, or something completely unknown, but chemical analysis of its tissues eventually confirmed its fungal nature. It likely fed by breaking down organic matter-decaying plants and microbes recycling nutrients in this early land ecosystem. Imagine walking through this ancient world. There are no animals, no buzzing insects, just strange, finger-sized mosses carpeting wet stone, and scattered among them, towering fungal columns reaching skyward, casting shadows over the silent ground. Beside the mosses and fungi, another group of plants was starting to evolve eons with an internal plumbing system. These were the vascular plants, and they were about to change everything. Unlike mosses, vascular plants could stand taller. They had tube xylem and phloem that moved water and nutrients up through their bodies, and they could grow stems, branches, and eventually leaves. The first known vascular plant, Cooksonia, was tiny, just a few centimeters tall. It had no leaves and only basic branching stalks, but it had a key advantage: strength. Cooksonia could survive farther from water sources, explore new environments, and reproduce more efficiently with spores. Other early vascular plants followed, like Silophyton, Baragwanathea, and Zosterophyllum. They looked like green pipes, splitting into forked stems with spore capsules on top, simple but effective. These plants, alongside mosses and fungi, formed Earth's first land-based ecosystems. And at the base of it all, the fungi played a hidden but vital role. Deep in the soil, mycorrhizal fungi formed networks with the roots of these early plants. They traded nutrients, offering minerals and water in exchange for sugars made by photosynthesis. This symbiotic partnership allowed plants to grow faster and stronger, while fungi expanded their reach underground. This alliance between plants and fungi still exists today. In fact, nearly all modern plants rely on fungal partnerships beneath the soiler relationship that began right here in the Silurian. But life on land was still fragile. There were no trees to hold the soil, no animals to spread spores or seeds. Erosion was constant. Floods and storms could wash away entire patches of moss and ferns. And oxygen levels were still rising slowly, not yet enough to support complex animal life on land. Yet every spore released into the air, every fungal hypha that burrowed into rock, was a step toward transformation. Over millions of years, these tiny pioneers reshaped the Earth's surface. They weathered stone, trapped sediments, and helped form the first layers of soil. And as they released oxygen, they gradually changed the atmosphere, making it more breathable for future life. This was the silent conquest of land, not by roars or claws, but by green filaments, creeping roots, and towering stalks of fungus. Beneath the shallow waves nearby, reefs of coral and sponges continued to grow. Jawless fish swam in schools. Sea scorpions hunted in tidal pools. But above the waterline, on the stony margins of rivers and coastal cliffs, evolution was preparing for its next move. The Silurian period would end after 24 million years. But by then, the foundation had been laid. The stage was set for a new explosion of life on land, the rise of insects, spiders, and eventually, vertebrates. But none of that could have happened without the earliest mosses, vascular plants, and those strange, pointy fungal towers that once ruled the landscape. The Silurian world was not lush. It was not green in the way we know it today. It was raw, minimal, and alien. But it was alive, and in those quiet, plant-covered rocks and fungal forests, Earth's surface was waking up for the very first time. The Silurian period, spanning from about 443 to 419 million years ago, marked one of the most crucial turning points in Earth's history. It was the time when life, slowly and carefully, began its journey from water to land. But before we reach the shores, we begin in the seath cradle of all early life. Most of the continents during this time were clustered near the equator. Towering land masses like Laurentia, Baltica, and the supercontinent Gondwana dominated the map. But much of the Earth's surface was still submerged beneath shallow tropical seas. There were no trees, no animals on land, just bare rock, quiet coastlines, and endless water teeming with life. The global climate had stabilized. The glaciers that had once gripped the southern hemisphere in ice had retreated, causing sea levels to rise. Warm, shallow waters spread across vast regions, creating perfect environments for marine life to thrive again. Beneath the waves, life rebounded with stunning diversity. Trilobites, which had survived the mass extinction, once again roamed the seabed. Brachiopods anchored themselves to rocks, filtering nutrients from the water. Corals, both solitary and colonial, flourished and began constructing the planet's very first reef systems. These reef-building corals, known as tabulate and rugose corals, laid the foundation for complex marine ecosystems. But it was the rise of fish that marked the Silurians' most significant evolutionary leap. The seas swarmed with strange, jawless fishagnathan's covered in armor-like plates. They glided silently through the water, using gill slits to filter oxygen. Species like Cephalaspis and Pteraspis swam with flat, shield-shaped heads and long tails, an early glimpse at what vertebrates would one day become. And then came the Eurypterids, the sea scorpions. These apex predators, some growing over 2 meters long, ruled the Silurian seas. With powerful claws and paddle-like limbs, Eurypterids hunted anything they could overpower. They were among the most fearsome creatures of their time, fast, adaptable, and built for domination. In these thriving marine worlds, competition fueled innovation. Eyes became more advanced, body shapes diversified. Some fish began to develop primitive jaws, setting the stage for future predators that would forever change the balance of life in the oceans. While life beneath the surface was accelerating, something remarkable was also happening above the waterline. On land, the silence was being broken. The Silurian period saw the rise of the first vascular plants, with specialized tissues that could transport water and nutrients. Cooksonia, one of the earliest known examples, stood only a few centimeters tall. But it was a game changer. With the ability to grow upright and reproduce using spores, these primitive plants began to colonize the edges of rivers, lakes, and coastal zones. They were small, but they changed everything. Their presence began to stabilize soils, reduce erosion, and alter the chemistry of the atmosphere. Mosses and liverwort-like plants also appeared, forming green patches along damp, lifeless ground. And below these new pioneers, fungi formed complex symbiotic relationships with their root-san alliance that still shapes ecosystems today. As these simple plants spread across the land, they exhaled oxygen into the atmosphere. Slowly, the air began to change. This rising oxygen would eventually support larger land-based animals, but in the Silurian, it was still a world in transition. Insects and vertebrates had not yet arrived. The land was still mostly barren rocky plateaus, volcanic plains, and river deltas cloaked in fog, but the green invasion had begun. From tiny patches of moss and vascular stems, life was laying its claim to the continents. Back in the oceans, the reef systems continued to grow. Corals and sponges created vast underwater cities. Crinoids feathered. Plant-like echinoderms waved, gently with the currents, catching particles of food. Gastropods and early mollusks crept along the seafloor, exploring every niche. Many species developed hardened shells or spines as defense mechanisms. Predators were evolving, and so were their prey. The Silurian was an arms race of biological creativity, and every adaptation counted. During this time, the Earth's magnetic field also underwent changes, and the continents drifted ever so slowly across the globe. The atmosphere, though still lacking oxygen compared to today's levels, was becoming more stable. Volcanic activity persisted in some regions, releasing gases and minerals that enriched the oceans. These nutrients fueled plankton blooms, which in turn supported larger marine animals. The Silurian wasn't just a time of survival, it was a time of transformation. With the growth of plants on land and the rise of fish in the oceans, two separate worlds were evolving simultaneously, and both would soon collide in the next chapter of Earth's deep history. As the Silurian period drew to a close, the Earth stood on the edge of another leap. The Devonian period, the age of fishes, was coming, and with it, the first real conquest of land by animals.